scene, we noticed that there was blood spatter on a file folder. I'm not using file folders for this lab experiment because it would be hard to recreate everything that we need on a file folder. So we put it on regular computer paper. So I have recreated the scene spatter on computer paper. That way it's on the same paper as the spatter that we're testing at different heights. So we have information for spatter at, it's organized here, 0.25 meters, 0.5 meters, 1 meter, 1.5, and 2 meters. So blood was dropped from these heights onto this paper, and the attempt was to get 10 good spatter that could be measured with the caliper, the diameter measured with the vernier caliper. You or students in class that were running a little bit ahead have already collected this data, and this data will be available on Canvas so that you can see what the average diameter was at each of these heights. In your PBS course file, in your PBS comp book, you need to set up a page, and it needs to be we need 2 pages side by side. Your graph doesn't look like this. Your graph looks like this. But you'll put the graph on the left and you'll put the lab setup on the right. So you need 2 pages side by side. On the right-hand side, you can give it a title. This is our blood spatter. The question that we're trying to ask, or the question that we're asking about the spatter is what position was the victim in when the blood spatter was formed? So you ran a Kastle-Meyer test on all of the red substances that were at the scene. The Kastle-Meyer test was able to identify the spatter and the stain on the table as blood and the red stain on the flask as not blood. So now that we know that the spatter and the blood on the table, there was blood in the spatter and blood on the table, now we're going to continue to analyze it. In the blood typing test, you look to see which blood type, A, B, or O, each blood was. And so now that we know it was blood and we know what type of blood it is, now we can continue to analyze it. So, as it turns out, there is a scientific principle that the higher up or the lower down the blood is when it falls, there is a pattern to the size, the average size of the diameter. So we can use that information in order to determine what position the victim was in when the blood was formed. So you're given that question. H, of course, means hypothesis. You are going to write your hypothesis. When you write your hypothesis, you're going to indicate, what position you think this person was in. So sitting, standing, whatever. I mean, there are a gazillion different positions. So don't limit yourself to, okay, this sitting is a position. It has to be that. So think about what you think might have been happening over there. What's the picture that you are putting together in your mind as to what happened to Anna in the moments before she passed away? And then decide on a position. So the thing is that whatever position you decide on, you have to have a general idea of about how far up off the ground would she have been in that position. So it's been determined that the blood spatter that was on the folder came from the cut on Anna's head. So Anna had a cut on her head. It created the pool that was on the floor, and it's determined that it also most likely created the spatter. So considering where she might have been, and the cut was on her head, grab a meter stick, grab the meter stick side, not inches, because inches isn't going to correlate here to what we're doing, the side with the centimeters on it, get in that position, get 2 meter sticks if you need to, whatever, and get a general idea of how many centimeters off the floor do you think that spot on her head was where she lost the blood, and give that as part of your hypothesis. So your hypothesis should indicate about what position she was in and about how far off the floor in centimeters you predict that the victim was in when the blood spatter was formed. IV, independent variable, so you're going to fill that in. DV, dependent variable, you're going to fill that in. CV, controlled variable, you're going to fill that in. We need a little data table because, and I should have put it right next there, but because I've got my metric units up here, I don't have to put 0.25 meters, 0.5 meters, 1 meter, because height in meters, so that means all of these numbers are in meters. Average diameter, and so average diameter of the spatter at that different height, those will be compiled for you and put on Canvas. You, however, will have to find the average diameter of the scene spatter. So when you are ready, you can request, and these are copies. This is the best I can do. These are copies. This is the setup of the scene spatter. This is not a good spatter to measure. Looks like I've got 2 drops that are in the same spot, so I don't want to measure the diameter of that because that's going to be misleading. This is a good spot. This is a good spot. This is a good spot with the exception of this little tail that it has right here. It looks like something got drug across that. So you can do the diameter of this one, excluding that tail. And this one's okay, but just make sure you get across the diameter. So you are going to use a caliper, and you are going to measure the diameter of those spots. Do not write on my sheet. Once you find the diameter of those spots, find the average diameter and put it in your comp book. Then you need to take that information and use it to determine where the person was at or what position they were in. You're going to do that, you're going to analyze it by graphing. So you need one of these graph sheets. Height dropped from in centimeters, so you're going to have to do a little bit of conversion. Diameter of blood spatter in millimeters, so keep that in mind, but our vernier caliper, when you're measuring with this caliper, you are measuring in millimeters. Then once you get that information, you're going to plot your data. So, and I'm just making this up, I honestly can't even remember and have no idea. So let's say I have numbers that plot on here and look kind of like this. Well, that's not going to work because that's off the graph. Okay, so let's say I have stuff I plotted on here and it looks kind of like that. The instructions from Project Lead the Way talk about a standard curve. And so that usually does mean that we have a curved line. For us, we want to have a trend line. So our trend line, our line of best fit, we want to go through as many of these points as possible with a straight line and have as many above as below as possible. We want it to be through the middle as best as we possibly can. So if I'm eyeballing this, and I would highly recommend a ruler. There are rulers in the back supply cabinet in the classroom. So trying to get as many above as below, trying to get it through the middle as best as I can. So here's my line of best fit. Let's say my data looks more like this, something like that. Well, then obviously my trend line is going to look a little bit more something like that. So just take a look at the points that you plot and draw yourself a line of best fit. So then the question becomes, I have this line. I need a better marker. Does it work? Nope, that doesn't work either. Hang on. All right, so I have this line. This line, let's say here's my data points on here. This line shows the overall trend, what happens with the diameter of blood spatter as we increase the height. So if I know the average diameter of the blood spatter from the scene, which I should because I'm going to find it from this sheet right here, then I can use this graph in order to find the height at which the person was at. So use your variables, manipulate your variables, and use this graph in order to find the height at which the person was at. In order to draw your conclusion, we're going to do a kind of brief CDE conclusion. So C is your claim. Your claim answers the question. So let's say my hypothesis was the victim was sitting down. Then I run through all the data and I analyze it and I use my graph, and my graph says it's impossible for her to have been sitting down to create that spatter. My claim answers the question. So even though my hypothesis, the data did not support my hypothesis, even though the data rejected my hypothesis, my claim is answering that question. So you might have to do a little bit more of looking into it. So the data shows that it's impossible for her to have been sitting down, so she had to have been kneeling down. So according to the data, she was kneeling down. So that's my claim. The victim was kneeling when the blood spatter was made. D is data. What data supports that? I don't need the whole graph. I don't need all of this stuff because it's all right there. Pick the items. There's probably maybe 2 or 3 items that you would choose, and you're just going to list them. What are the 2 or 3 things, the 2 or 3 pieces of data that let you say the victim was kneeling when the spatter was made? Then explain. How do you know the victim was kneeling? Was your hypothesis, did the data reject, or the data failed to reject the hypothesis? And a little bit of blurb, the biological process, once again, in this situation is, what is the pattern? So according, when you do your graph, what's the pattern that you saw according to your graph? So on this one right here, I would say that as distance increased, the diameter of the spatter decreased. So something along those lines right there. So your claim, 1 sentence, answering that question. What was the actual position that the person was in? Your data, 2, 3 pieces of information that allow you to make that claim. Then explain. Within your explain, you're going to talk about how does that data allow you to say the claim. How do you know that? The data rejected, or the data failed to reject your hypothesis, and maybe why. Explain why you can say that. And then your biological process. What's the general trend that you saw in the graph? What happens with the diameter of blood spatter as height increases?